Okay, so previously we have studied simple harmonic motion and their characteristics, as I have mentioned. So today we are going to study superposition of the two simple harmonic motions. So you might have studied superposition in numerous occasions in physics, like superposition of two forces and things like that. And superposition is very important. Okay, so superposition means in this case the resultant of two or more harmonic vibrations will be taken to be sum of the individual vibrations. Okay, so if two or more simple harmonic motion acts on a body, so their resultant will be the sum of the individual vibrations. So that is the principle of superposition. It's a very important thing. Okay, so now in first case, we are going to combine two waves which are collinear. That means they are acting along a line, either on y-axis or z-axis. So they are two collinear simple harmonic motion, and their periods are equal. That means their frequencies are same, however differing in amplitude and phase, and their amplitude and phases are different. Okay. So you have come across this thing when you have studied interference of light waves. Okay, so light wave is an electromagnetic waves that is also follows some sinusoidal. So we consider two simple harmonic motion acting on a particle, and they are represented by, first one is y1 equal to a1 sine of omega t plus alpha 1. So the first wave. One means the first wave. Okay, amplitude of the first wave is a1, and frequency is angular frequency is omega, and phase or epoch is alpha 1. And the second wave is wave number 2 is y2 is equal to a2, which is the amplitude of the second wave. As I said, amplitude are different and angular frequency are same. That means frequency or period are same, and then phases are different, alpha 1 and alpha 2. Where y1 and y2 are the displacement of a particle due to two vibrations. As I mentioned, a1 and a2 are the amplitude of the two vibrations, and alpha 1 and alpha 2 are the epoch or phase angles. Now we will find out the superposition of the resultant of these two displacement. So hence, from the principle of superposition, resultant displacement will be the algebraic sum of the above two vibrations. That means you will add y, the resultant vibration y will be sum of y1 plus y2. So this is a1 sine omega t plus alpha 1 and a2 sine omega t plus alpha 2. So you know that sine a plus b formula. This is a1 into sine omega t cos alpha 1 plus cos omega t sine alpha 1, and a2 multiplied by sine omega t cos alpha 2 cos omega t sine alpha 2. And then you just rearrange this one, taking sine omega t common. So it will be a1 cos alpha 1 plus a2 cos alpha 2. And here is a1 sine alpha 1 plus a2 sine alpha 2. Now we will approximate. We will choose this one as something, and we will choose this one as, so we will choose a1 sine alpha 1 plus a2 sine alpha 2 as a sine phi, and a1 cos alpha 1 plus a2 cos alpha 2 as a cos phi. So if we substitute, instead of this one and instead of this one as a sine phi, and instead of this one as a cos phi, so you form the formula become here. Formula become a cos phi sine omega t plus a sine phi cos, which can be written as a sine omega t plus. Okay, by this, if you choose a sine phi is this, and a cos phi is this, and if you square both sides, this will be a square sine square phi and square of this one, and it will be a square cos square phi and square of this one. And then if you add these two, squaring and adding, so this will be a square into sine square phi plus cos square phi, which is a square, and this is square, and then, okay, so if you expand that one, so this one, and then taking sine square alpha plus cos square alpha as 1. So this S square will be A1 square plus A2 square plus twice A1 A2 sine of alpha 1 and then sine alpha 2 twice A1 A2 cos alpha 2. If you take twice A1 A2 common, this will be sine alpha 1 sine alpha 2 cos alpha 1 cos alpha 2, which is cos of alpha 1. Note here alpha 1 minus alpha 2 cos A minus B. And then if you divide this one, if you choose this one as equation number 1 or something as you wish, and this is equation number 2, and if you divide 1 by 2, this will give you tan phi. Tan phi is A1 sine alpha 1 plus A2 sine alpha 2 divided by this one. Okay, so that means we calculate here. You can calculate A from this equation. This is equation number 3. You can calculate A from here, and then you can calculate phi from this equation. Okay, this equation is 4. So the resultant displacement will be A cos sine omega t, S cos phi sine omega t plus A sine phi cos omega t, which can be written as A sine omega t plus phi. So what we are seeing that the resultant of the two simple harmonic motion is another simple harmonic motion because it's a sinusoidal wave, but their amplitude will be A and phase angle will be phi. Okay, and A can be denoted by equation number 3 and phi is denoted by equation number 4. Okay, thus the resultant motion is also a simple harmonic motion of same frequency. Look, omega remains same, frequency remains same frequency or same period, but amplitude is A and phase is omega t plus phi, and acting on the same straight line because it's along the y-axis. So resultant of the two simple harmonic motion is another simple harmonic motion, and if they are if the frequency of the component are same, so the resultant of the two waves, frequency of the resultant wave is also remain same, but the amplitude will be different and phase will also be different. Now we are going to study some special cases. So these special cases are, suppose the simple harmonic vibration of the same phase. That means alpha 1 is equal to alpha 2 is equal to alpha, same phase. So in that case, if it says same phase, you see, if you remember in equation number, what was the equation number? Equation number 3, this one, in equation this one, okay, this one, S square is equal to A1 square plus A2 square plus twice A1 A2 cos alpha 1 minus alpha 2. If alpha 1 and alpha 2 remain same, so alpha 1 minus alpha 2 will be 0. So it will be cos 0. Cos 0 means 1. So that means S square will be A1 square plus A2 square plus twice A1 A2 cos of alpha 1 minus or S A1 square plus A2 square plus twice A1 A2, which is A1 plus A2 and whole square. Okay, now if the amplitude are same, then it will be just twice A. It will be A will be just twice A. Okay, so in this case we have chosen only the same phase. If it is same phase, then Y will be A1 plus A2 sine of omega t plus alpha. Just sum of the, so the resultant amplitude will be the sum of the amplitude of the individual vibration. Okay. And simple harmonic vibration in opposite phase. So opposite phase means alpha 1 minus alpha 2 will be odd multiple of pi, odd number multiple of pi. If it is odd number multiple of pi, cos pi means minus 1. So the formula will become A1 square plus A2 square minus twice A1 A2, which is A1 minus A2 square. So the amplitude, resultant amplitude A will be the difference of the amplitude of the individual waves. Okay. Now in addition of these two, if the amplitude are same, A1 A2 same, so A will be 0. That means amplitude will be 0. This is an important case of interference of light, which you have studied earlier. Okay, and you have seen that when the amplitude are same and their phases are opposite phases, then there's a resultant interference resultant intensity becomes 0. That means this is a special case of destructive interference. Okay. On the other hand, if A1 plus A2 is same, here in this case amplitude become double, which you have studied in case of constructive interference of light. In your first semester, you have studied this. Okay. So far we have studied the superposition of the two collinear waves. That means the waves are acting along a line, following the and their frequencies are same, but the phases are different. And then we have analyzed this resultant when the phases are same and when the amplitude are also same. What happens? We have studied this thing. Now the second case is, in this case, we're going to study what happens if the two simple harmonic motion acts perpendicular to each other. That means one motion is along the x-axis, another motion is along the y-axis. One simple harmonic motion is along x-axis, along y-axis. Then we are going to find out the resultant of these two waves. And this has got some when the two waves acting perpendicular to each other, when they are perpendicular to each other. So when a particle is subjected to a simple harmonic vibration acting at right angles to each other, then the shape of the resultant curve traced out by it is not a simple one, and it depends upon the amplitude and period of the period and phase difference of the two constituent waves. However, there will be a closed curve, and this closed curve is called Lissajous figure. That's a very important thing. Okay, when two simple harmonic motion acts on a particle at right angle, that means one is along x-axis, another is along y-axis. That means their angle between them is right angle, 90 degree. Then you will see some closed curve, and these closed curves are called Lissajous figure. Lissajous is the name of the scientist, so it's called Lissajous figure. Okay. Now we are going to combine our first case is in case composition of the two mutually perpendicular simple harmonic vibration of equal periods, means equal frequency, but differing in amplitude and phases. This is the simple one. So in first case, we chose first simple harmonic motion is acting along x-axis, and we have chosen that one is x equal to a sine omega t plus alpha 1. And the second wave is y equal to b sine omega t. So look, their amplitude are different, but the frequencies are same, phases are also different. This has got 0 and this one is alpha. So x and y represents the displacement of a particle along x-axis due to the influence of two simple harmonic vibration acting simultaneously on a particle in perpendicular. Here the vibrations are the same, vibrations are of the same time period, but different amplitude and differing in phase angle, as I have mentioned earlier. Okay. So from this equation, sine omega t will be y by b. So sine omega t is, you can take a note, sine omega t equal to y by b. Okay. If sine omega t y by b, then you can find out cos omega t will be square root of 1 minus sin square omega t. So sine omega t is y by b, so it will be square root of 1 minus y square by b square. You know that one, it's very simple one. And then from this equation, x by a will be sine omega t plus alpha. So sine omega t plus alpha means sine omega t cos alpha, cos omega t sin alpha. So you know the value of sine omega t from here, and you know the value of cos omega t over there. And substitute the value of sine omega t and cos omega t in this equation. You can give a number in this equation. If you substitute sine omega t and cos omega t in this equation, this equation become and then rearrange some. This will become x by a equal to y by b cos alpha plus square root of 1 minus y square by b square, and then sine of alpha. Sine alpha is outside the square root sign. And then if you change the side, x by a minus y by b cos alpha is equal to square root of 1 minus y square by b square sine alpha. And then if you square both sides, so this will be x square by s square, and then b square is y square by b square cos square alpha, and then the cross term, twice a b term is this one, and that must be equal to 1 minus y square by b square into sine square alpha. Okay, and then here you have y square by b square cos square alpha, y square by b square sine square alpha. So if you take common, x square by s square plus y square by b square common, sine square alpha plus cos square alpha, which value is 1, that must be equal to sine square alpha. So x square by s square plus y square by b square minus twice xy by ab cos alpha must be equal to 7. So that's the result. This represents the general equation of an ellipse. You know, this is a general equation of an ellipse. Okay. Thus, due to the, so our conclusion is, due to the superimposition or superposition of two simple harmonic motion, the displacement of the particle can be shown in figure in the next page. The resultant vibration of the particle will depend upon the value of alpha, okay, ranging from 0 to pi. So we have shown here. When alpha is equal to 0, so alpha equal to 0 and alpha equal to pi are equivalent case. Alpha equal to 0 or pi or integer multiple of twice pi, they are same. So if alpha equal to 0, cos alpha will be cos 0 is 1, and sine twice pi, sine 0 is 0. Okay, and again cos twice pi is also 1, and sine twice pi is 0. So in that case, the previous formula, the formula of the ellipse, this one, if you put this one is 0, this one is 1, it will become x by a minus y by b square equal to 0, or x by a equal to y by b, which is an equation of, so this will become x by a minus y by equal to 0, or y equal to b by a into x. And you know, this is a simple equation of a straight line, like y equal to mx that you have studied in your college level geometry is mx, y equal to mx, okay, and slope of the curve is b by a, okay. So either, so the particle will vibrate along that direction, okay, along that direction. So it's a closed curve. It will go there, come back, go there, come back. So again, it will be simple harmonic. It will start to vibrate that one. So this represents the equation of straight line BD here. It's straight line BD. That is, a particle vibrates simple harmonically along BD. Okay. And next case is, if alpha equal to pi, then sine alpha will be 0, cos alpha will be minus 1. So again, this will be an equation of, so if you substitute the value of sine alpha and cos alpha, okay, so sine alpha is 0, so that right hand side will be 0, but in this case it will be plus now. Okay, so if it is plus, so this will be actually plus here. So y will be, in this case, y will be minus b by a into x. This also represents the straight line. However, this straight line will be along AG, along the, so the slope of the curve will different. Okay, so along AG, like this one. This is the case. So we have considered this case, alpha equal to 0 and alpha equal to pi. And if you choose intermediate between them, the curve will be look like that. So we're gonna explain. And also, if we choose alpha equal to pi, alpha equal to 0 and alpha equal to pi is same thing. Okay, so now what happens if alpha equal to pi by 2 or 3 pi by 2? Pi by 2 means 90 degree. 3 pi by 2. So in that case, sine alpha will be 1 and cos alpha will be 0. If sine alpha is 1, so right hand side of the equation will be 1, and the left hand side cross term, the term having cos alpha will be 0. So it will be x square by s square plus y square b square equal to 1. So this represents the equation of an ellipse. Ellipse EH, this one, EHGF. With A and B are the semi-major and semi-minor axis. Okay. And if A and B are same, in addition to alpha equal to pi by 2 or 3 by 2, A and B are same. Okay. Then A and B are same. So this become x square plus s square equal to s square. This represents the equation of a circle of radius A. Semi-major and semi-minor axis is over here. So semi-major axis A, semi-major axis B for the ellipse. Okay. And for the circle, these semi-major axes become same. When they become same, this become a circle of radius A. Okay, that's the end of this lecture. So I'm going to give you a homework. Homework will be, in this case, we have find out the resultant Lissajous figure for two simple harmonic motion acting right angle to each other. Okay. Now, however, their frequency remains same. Now, next case will be if their frequency become double of the one frequency become double of the other, then what will be the Lissajous figure? That will remain the homework. So, as the network is disturbing, I'm gonna